All right, so I'm out, and I don't know if I'm gonna use this video in the future, but today I'm absent because I'm out here trying to make a difference, trying to change people's lives, I guess you can say that. So we went through these two problems, and I'm pretty sure we're good with those based upon you all's actions and in class. Third block just stares at me. At least fourth block sometimes talks to me. Third block treats me like some kind of, I don't know. All right, let's look at the bottom. We skipped this problem. It says a taxi company charges $2.50 plus $1.10 for each mile driven. Write an equation to represent this situation. Use this equation to determine how far you can travel if you have $10. What is the minimum amount of money you need or you will spend? Minimum amount of money you will spend. What is the domain and the range of the function? All right, so there's several questions being asked, but we'll just write the equation. The first thing says write the equation. So a taxi charges $2.50 plus $1.10 for each mile driven. All right, so let's use D for dollars, total amount of dollars. I still don't have my writing tool. I think it's over $100 to buy. We'll get it one day. And then we'll say M is for miles driven. For miles. All right, so write an equation. So the amount of money I'm going to pay in dollars is equal to, a charge is $2.50, and then plus $1.10 per mile. Some people get rid of the zero. If you want to get rid of the zero, that's fine. I just left the zero there. Goes in the problem. All right. Write an equation to represent the situation. Got that. Use this equation to determine how far you can travel if you have $10. All right, so if I have $10, if this is 10, how far can I travel? That's what I'm looking for. Remember, if I write it, y'all, you write it. All right, so $2.50 plus 1.10 M is for miles. So I need to subtract $2.50 from both sides. That's going to leave me with $7.50 is equal to 1.10 M. And now M is for miles, so we divide both sides by 1.10. 1.10.
Will all IB ambassadors please report to Ms. Thornburg's office? All IB ambassadors please report to Ms. Thornburg's office.
All right, so we get M is equal to 6.818181. So we're going to just round to the nearest tenth. It doesn't tell us to round, so let's just round to the nearest tenth. So we have 6.8, what's that? Miles. Because we can go to 6.8 miles, so we can say 6.8 miles. M is equal to 6.8 miles. What does that represent? So let's make sure that, well, what is the minimum amount of money you will spend? So let's talk about this. D is for dollars. D is our range, and M is for miles. M is our domain. All right. So when we're talking about the domain, because we're going to deal with that first, what is the least amount of miles you can go? All right. So I can go 0 miles, and because miles are not restricted to integers, meaning that I can only go 1, 2, 3 miles. I can go 1.2 miles. I can go 1.8 miles. We can use inequalities. So M is going to be greater than or equal to, what's the least amount of miles you can go? 0. You don't have to go anywhere. Not at all. And according to this, with this money, right, with $10, I can only go 6.8 miles. That's the max. So now I say, well, what is the least amount of dollars I'll be paying? Now this is word. I don't want to say. I don't know. It'll come to me later. All right. So if D is for dollars, if I go 0 miles, how much money am I paying? I'm paying that $2.50 because I got into that taxi. Right. So I'm paying that if I don't go anywhere. All right. And then if I go the max amount of money that I have is $10. You have $10, so I'm going to spend at least $10. not at least, but at most $10. So that's my range. Now, some people, I said theoretically, that's the word I was looking for. If you deal with a situation, if you hop into a taxi, if you hop back out, you go nowhere, you might not be charged anything unless it's on your credit card. So sometimes people say, well, if I hop in the car and I don't go anywhere, I ain't paying nothing. So theoretically, some people think this number is 0. And sometimes I've said that number is 0 because, real world situation, if I get in the car, I don't go nowhere. You're not getting my money. All right. Mariah noticed, but Uber and stuff, they charge you for waiting these days. So whatever. Those days are over. Mariah noticed various combinations of $1 bills and $5 bills. You watch this if you need to see it again, because I'm telling you now that the quizzes has problems like this. So if you understand these next 3 problems, don't watch this video again. If you do not understand, watch this video again because it's going to help your grade. All right. If you're confident, go ahead. Go leave me. Bye-bye. See you later. All right. Mariah noticed that there are various combinations of $1 and $5 bills could make $23. So let X represent the number of $5 bills, and Y represents the number of $1 bills. I forgot to say this in the beginning. I'll put it on the website. All right, what is the domain and the range? So the X represents the number of $5 bills. So the domain, which is your X, would be what? Okay, so if I have 0 $5 bills, can I make $23? The answer is yes. So I can have 0 $5 bills. If I can have 1 $5 bill, can I make $23? Yes. What about 2? 2 times 5 is 10. And then that means I have 13. I should do this at the same time so y'all can see it. All right. Okay, yeah. I'll do it at the same time so you can see. I didn't do this when I did the notes, but I'm going to show you what I'm building here. So if I have 0 $5 bills, that means I have 23 $1 bills. Of course, the numbers are going backwards because I'm linking them up. If I have 1 $5 bill, then I have 18 $1 bills. Okay. If I have 2 $5 bills, which makes $10, that means I have 13 $1 bills. If I have 3 $5 bills, which means, I wish the numbers would line up, but they don't. If I have 3 $5 bills, which is $15, that means I have how many? Well, if you notice, I'm doing 15 from 23. That's going to give me 8. Okay? So if I have 4 $5 bills, that means I have $20. That means I now have 3 $1 bills. Chloe be talking about my she be bullying me. Y'all know Chloe's a bully. She's a straight up bully. I'm gonna redo my brackets. That's a little bit better. She'll be like, they look like a 3. She's a bully, y'all. Don't tell her I said it. All right, the function can be used. Oh, y'all good? Yeah, hopefully y'all good. The function can be used to determine the cost for a person to purchase tickets to a concert. A person can purchase up to 8 tickets. What is an appropriate domain for the function? So these should have equal to signs, and the bottom one shouldn't. All right, so if I can get up to 8 tickets, integers are numbers that are positive and their opposite. Positive whole numbers and their opposites. So that means these numbers will be negative. Can I have a negative amount of number of tickets? No, you're gone. Bye-bye. Can I have all positive integers that are less than or equal to 8? Well, that makes sense because that's 1, 2, 3, 4, 5, 6. Yeah, I have 0. That makes sense. All positive real numbers. Real numbers are decimals. I can't have half a ticket. So that's out. And all positive integers less than 8. Well, I can have 8. So that's out. All right. So the answer is B. As in, boy, I'm doing good. Come on, Mr. O'Neal. Kill this thing. Yes, sir. They're probably not even watching this part. Hamida, notice that various combination of nickels and dimes could add up to 65 cents. Let X equal the number of nickels. Let Y equal the number of dimes. What is the domain and the range of the function? In fourth block, we did not get to this question, so you might want to watch this. All right, so if I have combination of nickels and dimes, and I say X equals the number, X is the number of nickels, and Y is equal to the number of dimes. So if I have X for my domain, and it's the number of nickels, domain, can I have, in this situation, 0 nickels and make 65 cents? No. I'm going to do these both at the same time. But usually you won't see them at the same time because you'll see them in ascending order. But I'm going to do it for the sake of showing you the range. All right, so can I have 0 nickels? No. Can I have 1 nickel? Yep. If I have 1 nickel, that makes 5 cents. That means I have 6 dimes, right? So can I have 2 nickels? No. It makes 65 cents because 10 and 10 will never get me to 5. Can I have 3 nickels? Yes. That gives me 15 cents. And so if I have 15 cents, that means I have 5 dimes. Can I have 4 nickels? No, because that's going to give me 20 cents. I can't get to 65 with dimes. With pennies, I could, but not dimes. All right, so can I have 5 nickels? Yes. That's going to give me 5 times 5 is 25. It's going to give me 40 cents left over. I think you get the point. Can I have 6? No. Can I have 7? Yes. And that's going to give me 3. 7 times 5 is 35. 35 plus 30 is 65. Can I have 8? No. Can I have 9? Yes. That's going to give me 2 dimes. Can I have 10? No. Can I have 11? Yes. 11 times 5 is 55. And that's going to give me 1 dime. All right. Can I have 12 nickels? Well, 12 times 5 is 60. But that leaves 5 cents over, so I can't have any more dimes. So the answer will be no. This completes my domain and range. All right, let's go do the last problems. So independent variable. X is also called the independent variable. So we have domain. Hold up, buddy. I need you to type. Domain, or rather write. We have domain. We have, what else we call X? We call X the input. And now we are calling it the independent variable. The input variable that affects the dependent variable, the input or the X value, is also called the domain. If I had known they were all in here, I would have just did this. If I had read it beforehand, I would have just did this. All right, so we have 3 names. X can be called input, dependent variable, and X values, and the domain. Sorry, 4 names for the same thing. And then Y can be called the dependent variable, my output, my Y values, my range, all called the same thing. All right, so if you think about this relationally, it's called a relation. Relationally, hey, X and Y, I'm sleepy, are in a relationship. X is independent and wants to break up with Y. X means X. Y'all see that? Y'all see that right? Y'all see that right there? I'm very creative. Yes, I am. X means X. But Y, who is dependent, clingy, keeps asking, why? Why do you want to leave me? Why don't you want to be with me? I think, yeah. So say, for instance, in third block, who can be in a relationship in third block? Say, for instance, these 2 people sit together. It's going to make it awkward for them. I'm not going to use them. Let's say that Jasmine, who I kept forgetting her name, so let's say Jasmine. Let's say Jasmine and Aiden Smalls. We're in a relationship. All right, I'm going to say Aiden. He looks clingy. So we're going to say Aiden is the why. Like, why, Jasmine? Why you want to leave me? You know, we've been together for 2 years. Why? And Jasmine's like, no, I want to be an X. I want to be independent. And what about fourth block? Fourth block. Let's see who can be in a relationship. What if Sadu and Courtney? Yes, I think that'd make a good couple. They're cute. They look cute together. What if they were in a relationship? Sadu is clearly the clingy one. Courtney, why don't you pick up the phone? Why don't you text me back? And Courtney's like, boy, bye. Get out of my face. All right. So if you are independent, you're the X, right? Because you want to break up. You want to be alone. Independent variable. If you're dependent, you're the Y. You're the clingy one, always asking why. These boys so clingy these days. I don't understand them. So in this function, Y equals 3x plus 4, the input or the independent variable, this dependent variable depends on the independent variable because you don't know what Y is until you know what X is. All right, that's that lesson. So when we look down here, it says Mr. Mackers. Yeah, this video is longer than I wanted it to be. I guess I was clowning with these relationships. Mr. Macker's soccer team is having a car wash to raise money for new uniforms. C stands for how many cars are washed, and I stands for how much money they raise. Why is it I? That doesn't make any sense. All right, so what depends on what? So C is for cars, and then I is for how much money they raised. All right, so does cars depend on the money, or does the money depend on the cars? Well, you won't know how much money you have until you wash cars, so the money depends on the cars. So in this situation, when we get to X and Y, the money would be Y, and then the cars would be X. Yvonne, or the girl I grew up with was called Yvonne, reads about 20 pages a night before she goes to bed. N stands for the number of nights she has read, and P stands for the number of pages. Okay, so what depends on what? Does N depend on P, or does P depend on N? All right, so let's think about it. So nights will keep going on whether I read or not. So the number of pages I read depend on the number of nights I'm reading. Okay? Time is always independent. It don't care about nobody. It's going to move on whether you ready or not. Ready or not, here I come. You can't hide. Y'all don't know nothing about that. Y'all don't know nothing about that. During the first game of a season, a team scored 30 points. Over the course of the season, the team improved by 2 points per game. Y'all get this. I'm done. This is baby stuff. Like, y'all can read. I'm not going over any more of these problems. All right, Mr. O'Neal. It's been a great time. You're going to watch this video. I don't know how y'all can do quizzes when this is almost 20 minutes long. So, yeah, I'm probably going to shorten this quizzes, or I don't know what I'm going to do. You'll find out when I make the page. Have a great life. Talk to you later.